Good evening. Can you hear me? Sorry, I was late today. Good evening.
Good evening, sir.
Okay. Okay, actually, the purpose of this session now, nowadays we doing heat lesson. Adil, you came, no? What happened? No, I'm message at the Okay. Good. Okay. The purpose of this session is actually now we doing heat lesson. Heat lesson mean lesson number 9. We already completed 8 lessons up to now. 8 lessons. Lessons list we have complete 8 lessons. Measurements. Quickly, I will remind you. Revise measurement and forces. Third one, rotational motion. Fourth one, mechanical properties of matters. Fifth one, trigonometry and area volume. Seven, work energy power. Work energy power. Eight one coordinate geometry. Coordinate geometry, our final lesson. Okay, 1, 2, 3, 4, 5, 6, 7, 8, and part of Pythagoras theorem completed. We have another small part, Pythagoras triples. Pythagoras triples only we have. Right. That means it's a physics lesson, force physics lesson, rotational motion physics, mechanical properties of matters physics, trigonometry maths, area volume maths, work energy power physics, coordinate geometry maths. Actually, we have 5 maths lessons. From 5 maths lessons, trigonometry and area volume, coordinate geometry. 3 lessons completed. We have only descriptive statistic actually. Pythagoras theorem you already know. Okay, we have, I'll explain, but I'll get a special session and I'll explain about Pythagoras triples, that you know. Pythagoras triples. Okay. That's a summary we completed up to now. And how many physics lessons? 1, 2, 3, 4, 5 physics lessons completed. And we have another 3 physics lessons, electricity, fluid mechanism, mainly electricity and fluid mechanism. They are the main lessons. Okay, after that, fluid mechanism, electricity and heat. Now we doing heat lesson already started. Then we have another 2 physics lessons. Physics lessons are they guide in 2. Electricity and fluid mechanism that we can discuss in grade 30 next year. Next year mean may avruddham karna. Okay. The main part, the main thing is still we didn't start any chemistry lesson or biology lesson. No any chemistry or biology lesson started yet. No any chemistry or biology lesson started yet. Okay. Our next lesson actually the after heat lesson, this is our 9th lesson. Lesson number 9, heat energy. After heat energy, based on this basic knowledge, we can start our first chemistry lesson. It is thermochemistry. Thermochemistry. After that, we can start kinetic chemistry. Kinetic chemistry. As 12 lesson, we can start biomolecule, biomolecule, our first biology lesson, biomolecule. Okay, actually, after this part, my right side list of lessons always interconnected. Always interconnected. Actually, grade 13, all lessons are grade 13 final term of grade 12 and grade 13 lessons always interconnected. They without this basic knowledge, you can't understand thermochemistry. Without thermochemistry, you can't understand kinetic chemistry. Without the biomolecule is a biology lesson. Without biomolecule, you can't learn, you can't understand lesson number 13, natural products. Natural product actually second part of the biomolecule, but biomolecule is a biology part in our syllabus, but it is a lot of parts based on chemistry, basic chemistry, and natural products. Natural products, it's actually part of biomolecule lesson. Part of biomolecule lesson. Biomolecule and natural products mean natural products mainly two types. Natural products mainly two types. First one is primary metabolites and secondary metabolites. Okay. In primary metabolites example, protein, carbohydrates, lipids, that we discussing in biomolecule lesson. Protein, lipids, vitamins, enzymes, nucleic acids, about structures and their functions we discuss in biomolecule lesson. About secondary metabolites mean terpenoid, alkaloid, essential oil, phenols and polyphenols we discussing in natural products lesson. Natural products lesson. Okay, what I want to show you, actually after this heat lesson, all lessons has interconnection. After natural products, we can learn with this biomolecule and natural products knowledge, we can start industry chemistry. Most important lessons. Industry chemistry. Okay, that's our plan. But when we start this part, when we more focus into this section, this measurement forces, rotational motion, mechanical properties of matters, trigonometry, this left side basic lesson can be forget. Okay, that's our purpose of doing this session. Again, revise and keep refresh these basic lessons, because no more interconnection like this. Separate lessons, basic lessons of the syllabus. They are grade 12 first lessons, grade 12 basic lessons: measurement, forces, rotational motion, mechanical properties of matters, trigonometry, area volume is the first lesson, right? Work energy power, coordinate geometry. Okay, they are basic lessons. No any clear interconnection. But after this part, don't miss any class and you have to start now your working, your self-learning at least 2 hours per subject. Now you have to start working, because you don't have more, you have only very limited time now. Comparing with this low workload, not only our subject, you have another 2 subjects. Therefore, you have huge workload. But you have only 15 months. 15 months is not a long time, it's a very short time with your comparing with your workload. Hi. Okay. Today, please get your mechanical properties of matter, student. Mechanical properties of matter. we skip some part, right? In mechanical properties of metals, we skip one question. Do you remember? Heat tube. Yeah, I posted them Thursday. No issue. Tomorrow, we can continue. Tomorrow we're doing heat expansion. Heat expansion part, no problem. I posted all tube Thursday, but there was a late. Oh, give me a second. Okay, find your mechanical properties of matter state. Okay, in this tube, go to final page. Go to final page. We skip some question. I told after complete coordinate geometry lesson, we can complete this lesson. Okay, now coordinate geometry is completed. Okay, now you can complete this question. Okay, read the question. An experimental setup to find the Young's module of rubber is shown in the following figure. Do you remember Young's module? What's the meaning of Young's module? What's the meaning of Young's module? Young's module. This is a Young's module. Young's module means the ratio between stress and strain. I think you can remember. Ratio between stress and strain. What's the meaning of stress? Okay, within 5 minutes I will revise this lesson otherwise. Okay, in this lesson we discussing about elastic substance, right? Elastic substance. What's the meaning of elasticity? The elasticity mean when we apply external force on any object, if it is deformed, and when it is force release, if it is again returned to original position, that we called as elastic substance. Then what is the meaning of inelastic? Inelastic mean like paper. When we apply external force, it is deforming. deforming like this. When we apply external force, it's deforming, but when it is released, it's again not come to the previous position, previous shape. Okay, that's the inelasticity and elasticity. In elastic object, in this lesson, we mainly discussed about elastic substance, elastic objects, elastic materials. What are the examples? Elastic materials again return to original position. What are the examples? Rubber, wood, natural woods. What else? Natural woods. What else? Jimit? What else? Elastic substance. Elastic matters. Yes, glass, very good. Glass, glass elastic. What else? Glass, glass. Yes, they are the elastic materials. Okay. In this lesson, we mainly discussed about elastic substance. Okay, what we discussed different measures in mechanical properties of matters lesson. Okay, what are the lessons? What are the measures? Different quantities. The first one is extension. Extension or elongation. Extension. Extension or elongation. Same thing. Capital simple E. Simple E. What's the meaning of extension? When we apply external force on any object, when we apply external force on any object, the increasing length, the delta L is the delta L, increasing length is extension. Extension. As second quantity, we discussed about strain. Strain. What's the meaning of strain? Strain. This is L1. 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 L1 mean initial length. The increasing length is the extension. Increasing or decreasing length. If we apply compressive force, it is decreasing. Right? After that, we discussed about strain. What's the meaning of strain? The strain equal the ratio between the strain is the ratio between extension and extension mean E initial length, E over L1. Do you remember? The strain equal extension over initial length. Extension over initial length. The ratio between extension and initial length we called as a strain. Okay, finally we discussed about stress. Stress. Stress, I told mainly two types. What are the two types of stress? Tensile stress and compressive stress. If we apply tensile stress, increase in the length, that we called as tensile stress. Tensile stress, how to calculate stress? Stress equal perpendicular force divided by the cross section area. Perpendicular force divided by the cross section area. Okay, that we already discussed in the mechanical properties of matters. They are the quantities of explain elasticity of any material. Okay, that's the basic. Okay, let's move into the question. Now, what is the meaning of Young's module? Young's module. What's the meaning of Young's module? Okay, according to Hooke's law, Hooke is a scientist. He explained about the relationship between extension and applied force, right? Extension and applied force, the most important part. He explained about extension and applied force on elastic object. Yeah, according to his explanation, the applied force, if directly proportional to the applied force, directly proportional to the extension. Yeah, that is a Hooke's law. In the proportional limit, I already explained about proportional limit. I am not going to explain now. You can go through lesson if you can go through recordings if you've not covered this lesson. Okay, with all practicals we discuss this lesson. Now according to Hooke's law, the applied force directly proportional to extension, right? Directly proportional to extension. Yeah, that means if you got an equation, it is equal to Ke. What's the name of K? What's the name of K? Which constant? Yes, elastic coefficient. It's a constant that depend on material type. It is elastic coefficient. Elastic coefficient. Coefficient. Elastic coefficient. Elastic coefficient. Elastic coefficient or elastic constant. No, if not, we call as spring constant කියලාත් කියනවා. ගොඩක් තැන්වල මෙහෙමත් දෙනවා. Spring constant. Spring constant. අපි මේකට සිංහලෙන් කියන්නේ දුනු නියතය කියන. Spring constant. Spring constant. Spring constant. Spring constant. Spring constant. Good. Okay. That's a Hooke's law. Okay, according to Hooke's law, we can get another relationship if it is directly proportional, applied force directly proportional to extension. We can say stress also. Stress mean F over A. Stress mean perpendicular force divided by cross section area. Directly proportional to the strain as well. Strain mean E over L1. E over L1. F over A mean what is that? F over A. Met me. What's the meaning of F over A? Stress. Stress directly proportional to E over L1. What is the meaning? Strain. 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 This is not the full lesson. I am explaining very short way. මේ lesson එක මම කියන්න පුළුවන් කෙටිම ක්‍රමයෙන් තමයි කියන්නේ. හරිද? But I explained all equations. Okay. Now it is directly proportional. To remove this proportional mark, I have to add a constant that we called as a Young's module. This constant is a Young's module. This constant is a Young's module, same as spring constant. The Young's module is a factor that is dependent on the material type. Material to material, this Young's module value will be changed. Material to material will be changed. Now, if you isolate this Young's module, what happened? F over A, that means stress divide by the strain. Okay, that's why we call the Young's module is the ratio between stress and strain. F over A divided by E over L1. Do you remember what is the unit of Young's module? You met the unit of the Young's module? The unit of the Young's module? Yes, very good. Actually, this unit of Young's module, it is equal to the stress unit because strain no units. Do you remember strain don't have any unit? Strain no units because strain extension over initial length, both meter to meter cancel out. But stress unit is Nm minus 2 newtons per square meter or Pascal. Newtons per square meter or Pascal, both correct. Then Young's module unit also Nm minus 2 or Pascal. ഒന്ന് നോക്കായി ലെസൺ. This is the lesson. It's a lesson. Let's move into question. Give me a second. Okay, let's move into question. Can you see this? කියවන්න බලන්න මේ. Is it clear? Hear me? Now clear, right? An experimental setup to find the Young's module of a rubber is shown in the following figure. The cross-section area of the rubber is A. Capital A is the cross-section area. They are very important, this data, this basic data given in the question, very important for our future calculations, right? Okay, therefore we can highlight or underline these important terms. The cross-section area of the rubber tube capital A. The initial separation of the tube between X and Y. The initial separation of the tube between X and Y is L naught. What's the meaning of that? The initial separation of the tube between X and Y. The initial separation, actually that means the initial length. The initial length equal L naught. The initial, that means XY. The initial, the cross-section area A. Area. I will summarize this data. Cross-section area, it is capital A, right? The initial length, it is L naught. L naught. When a mass M is placed on a plate, it is a plate, measuring plate. Mass M is placed on the plate of balance. The point Y move down, and the new length of the rubber tube between X and Y become L. New length mean when we apply external force, the new length, that is final length, right? Final length mean final length it is L. Final length L. Consider G as a gravitational acceleration. The gravitational acceleration, simple G. Okay, they are the data given in the question. We have summarized that. Okay, write down expression for the tensile stress and very simple. Tensile stress and the tensile strain of the rubber tube using the symbols given above. Above given symbols, that is very important. Symbols given above, that's the most important thing. You can't write straight, now it is stress, no? If you write F over A, are you correct? Can you get marks? Completely wrong. Actually stress F over A. But how you F over A liyan you have to write down F over A, substitute according to the diagram. What's the meaning of F? F is the weight of the M, then mg, right? Mg is the weight. Divide by, divide by cross section area A. If you this answer, you can get full marks. Good. Met me. Mg over A. Mg over A. Okay, tensile strain, strain. What's the basic equation? Actually, this basic equation not compulsory, for your reference I am writing, right? Basic equation for strain E over L1. E over L1 mean extension of initial length. Extension of initial length. Extension. What is the extension? What's the extension? What's the extension? Extension mean delta L. That means length difference. Length difference mean final length minus initial length. Yes, good. L minus L naught. L minus L naught. Divide by L minus L naught. Divide by initial length. Initial length mean L naught, right? L naught. Can you cancel this L naught to L naught? You know? No, no, no. No, no. They are mistakes you did. This minus L minus L naught divide by L naught. Okay, please try second question. Okay, what happened? Please try to get this relationship. Now you can do it. Okay, what happened? The question asks, obtain an equation that relates the tensile stress and tensile strain using Hooke's law. Using Hooke's law. Okay, according to Hooke's law, what is the equation? Tensile stress and tensile strain. That's I explained actually. Previously I explained. Obtain an equation relates tensile stress and tensile strain. Okay, what is the equation? This is the equation, right? Make an equation. Yeah, this is the equation. This is the equation according to Hooke's law. This is the equation. But you have to note down this according to the symbols given in the, yes, very good, you meant. According to the symbols given in the question. Okay. Okay. According to Hooke's law, stress. What is the stress? Stress is mg over a. Wait. Mg over a directly proportional to the, not directly proportional, don't need them, equal to the, this Young's module, L minus L naught divide by L naught. L minus L naught divide by L naught. No, you meant. It is not an equation. Is that equation you answer? Your answer is a relationship. Division. The question asks equation. Okay, now that's the most important thing. That's the most important thing. Okay, what are the changing factors? What are the changing factors above experiment? Okay, actually, the mass is increasing, right? Mass is increasing by us. Mass එක තමයි අපි වෙනස් කරන්නේ. So what happened? Give me a second. There was a problem. Oh, sorry. Okay. Okay, mass is a factor changing by us. Mass එක තමයි අපි change කරන්නේ. The extension or final length actually automatically changing, right? According to the weight. Weight එක වැඩි වෙද්දී final length also increasing. Okay. According to that, rearrange equation is given in next question. Therefore, this basic equation enough for this question. Okay, that's the equation. You have to note down this as a equation. U1 is not an equation. I got. Others, any doubt? Vihanger? Understood? Hi. Now, what are the variables measured in this experiment? Variables. මොනවද අපි measure කරේ? Variable. What we measured? Let us give බලමු. Yeah, what's your answers? We measured initial length measured and final length measured and mass, right? Yes, the first one, mass, using triple beam balance or whatever scale, we can measure the mass, M, mass of the object. Sorry. Yes, the first factor, mass. Mass means simple M. And length difference mean second one, length difference, increasing length or final length කිව්වත් හරි. Final length L, final length mean L. Okay, they are the measured data. Rearrange the equation you obtained in 4b, b mean this one, as an equation of an straight line. And that is the most important thing I want to explain. Anitya Puluvan, there that other questions based on mechanical properties of matters. Now, how to measure elasticity, you meant? Come up, elasticity is not a quantity. Measuring data, mass we can measure, and length, that's only measuring, right? Venom kut measure karana. You met? Hi. Okay, how to rearrange this? That's the most important. I told, that's why we couldn't discuss this question. I couldn't discuss this question in the end of mechanical properties of matters because that is based on coordinate geometry. That's based on coordinate geometry. Okay, now how to rearrange this? Okay, now you already know what is the common equation of straight line. Y equal mx plus c is the equation, right? Y equal mx plus c is the equation, common equation of straight line. Okay, now how to rearrange according to this equation? Y equal mx plus c වලට හදන්නේ කොහොමද මේ? Okay, mass and final length are the measuring things. Okay, then make a, what are the changing factor? Which factor changing by us? අපි මොනවද change කරන්නේ? Mass, very good. The final length is auto changing, right? Final length is auto changing. Remember, always the factor changing by us should be x-axis. The factor changing by us should be x-axis. X-axis. X-axis means x. Yes, m is the x. X should be m. And final length should be y. Not y-axis. Y value. Y value. Hurry. Y. Okay. Now, most important. Okay. Now, what is our equation? The make up it online. I will erase that. Okay. What is our equation? mg over a. Simple. mg over a equal to y L naught divided by L naught. Okay, before easy calculation, I am going to cross multiply this. MgL2, make up cross multiply, then it is easy. MgL naught equal A Young's module L minus L naught. L minus L naught. Okay, this is a cross multiplied answer. Okay, now mass should be x. Mass should be x and final length should be L should be y. L should be y. What to do? Any idea? Final length, we have to multiply, no? Yeah, we have to multiply. Yeah. Now first AY we can get to this side. MGL naught divided by AY equal L minus L naught. L minus L naught. Okay, what is my requirement? To isolate L. To isolate L my requirement. Therefore, I can get this L naught into this side. L naught into this side. L naught එක මෙහෙට ගමු. Little bit make it චුට්ටක් complicated, but L naught get into this side. Then මම මේක මෙහෙම ලියන්නම් L equal එහෙම ලියුවත් තාල පටලනවා. Okay, මම මේක board එකේ හදන්න. It's very simple thing. හරි. මේ බලන්න. Clearly understand. This is very important. mg over a equal Young's module L minus L naught over L. Okay, this is the equation. Now for easy calculation, I am going to cross multiply this mg into L. L naught, sorry, mg L naught equal A Young's module L minus L naught, right? Now I'm going to change these two sides for you easy understand. Mame additional steps anne wala therun ganna. L minus L naught equal mg L naught. mg L naught. මම මේක අනිත් පැත්ත ගහගන්න. I change the side. Okay, now I want to isolate L minus L naught first. L minus L naught equal mg L naught divided by A Young's module. Young's module. Okay, I want to isolate L no, because y equal to L. Y equal L, the auto changing factor that we call as independent factor. Dependent one is x equal m. Now I want to isolate L, then L equal it's convert to plus. Now I am going to GL naught divide by A Young's module multiply by m plus L naught. Okay, this is a final equation. Now it is y equal mx plus c type, right? Y equal mx plus, no Vihanger, you have missed some data, right? No Dino, you have missed some data. Are you good? Now it is equal to y equal, see, y equal m, this part is m, x plus c. Understood or not? Dinul? Yumit, understood? Yeah, always any practical, we have a separate practical guide. In practical guide I will explain. Always only practical, like any practical, the dependent factor again, the factor changed by us, it is x, it's always x. The auto changing independent factor always y. Understood? Okay, now it is y equal mx plus c type equation. Hurry the steps diagram. Then after class you can go through again. These are very complicated question. Normally, you know, in exam question, fourth structured question, little bit complicated, little bit advanced question based on practicals. Now this is 2016 fourth structured question. Complete? Can I guess? Vihanger, understood? Remain parts very simple. Write the gradient and the intercept of the equation obtained in the part previous part equation gradient. Gradient ek ganna. M is a gradient. GL naught over AY. GL naught over A Young's module. This is a gradient. This is a gradient. Okay, what is the intercept? Intercept means C. Now you already know. This is intercept, L naught, right? L naught is the intercept. L naught is the intercept. Very simple. Draw a rough sketch of the graph using the equation obtained previous part. Yeah. Tell me if now it is a straight line. Am I correct? What's you meant? I couldn't understand. Okay. Am I correct? Vihenga. Hi, Balan. Dinul, am I correct? I am asking this graph. Yeah, it should be straight line. But is it moving origin? It is going to origin. Initial point again, 0, 0 point. No, why? It has an intercept. It's intercept like a 0 now. If it is intercept 0, our equation should be y equal mx type equation. Y equal mx type. If it is intercept 0, our equation should be y equal mx type, right? But it is our equation mx plus c type. Mx plus c type means it has an intercept. Intercept එකක් තියනවා කියන්නේ you can't draw මේ question එකේ අපි mark කරන්න ඕන you can't draw this type straight line completely wrong because the graph has a intercept. Therefore your graph should be like this. මේ මෙතන point මෙතනින් උඩ ඕන තැනකින් අඳින්න තියෙන්නේ. මේ cut වෙන තැන you can say L naught. That's all. Understood? Because y-axis cutting point is intercept, right? It is L naught. With me? Terna? Understood? You met? Graph එක තේරුණාද? Okay. If the gradient of the above graph drawn in part 4f, 4f mean 4f mean previous one. If the gradient of the above graph drawn in previous part is g, gradient equal g, obtain an expression for the Young's module of the rubber. Expression is asking, not a value. Expression just using symbols. Okay, now the Young's gradient already gradient gradient equal GL naught divided by L AY. GL naught divided by AY. AY means Young's module equal to G. Now expression is asking, you can isolate the Young's module. Okay, I'm going to cross multiply G AY equals simple G L naught. Young's module equal GA over GL naught. Understood? That's the expression. Priyanka? Terna? Dinul? Right. Okay, what are the reading of the rubber tube that required to calculate Young's module using the answer in previous part above? Hari. What are the what are the readings of the rubber tube that required to calculate Young's module using part G1? Again, make. Okay, what are the requirements? Another one. The G is the what's the G gradient? G is a gradient. You have to calculate initial length, and what else? Initial length is the first one. Initial length. That means L naught. What else? You have to get the cross section area. Cross section area. To get the cross section area. Now it is a rubber tube. You have to think. Now what is the shape of this? Rubber tube. Okay, what's the meaning of rubber tube? Rubber tube. Is it hollow or completely filled with solid? Tube it's a hollow it's a rubber tube. Now you have to think. Okay, to get our other requirement is cross section area. To get the cross section area, what are the data required? Internal diameter and external diameter. They are the requirements. Initial length we can get by meter ruler. Other requirement, the second one, internal diameter and external diameter. Internal diameter and external diameter. Using these both values, we can calculate the area, cross section area. Good. Write down the instrument with their least count. Remain part is measurement lesson question. Write down the instrument with their least count that can be used to obtain above 3 measurements. That means initial length L naught, internal diameter, external diameter. Okay, to get the initial length, sir, why did we took only gradient of the equation, not intercept too? For which part? I? Because it is given. If the gradient of the above graph is given as G, only gradient තමයි දීලා තියෙන්නේ. It is given. You mean? I find Young's module. Yeah, but intercept we don't know. You mean? The gradient value given using this gradient, I got a relationship. Okay. Okay. L not instrument meter ruler. No any other instrument meter ruler. Meter ruler. Least count 1 millimeter. Least count 1 millimeter, right? Internal diameter. What is the instrument? Vernier caliper, okay, but yeah, no problem. Additionally, we can use traveling microscope. Traveling microscope. Then අපේ syllabus එකේ නම් ලොකුවට ඒක ගැන කතා වෙන්නේ නැහැ. Vernier caliper okay. Vernier caliper. External diameter vernier caliper, no problem. Uh, 0.1 millimeter, 0.1 millimeter. If you want for external diameter, you can say micrometer screw gauge, no issue. Micrometer screw gauge, 0.01 millimeter. Okay, write an expression for the elastic potential energy stored in the rubber tube when some mass is applied to it. When some mass is applied to it. Mass means weight, right? Weight is a type of force. Draw a rough sketch of a graph to obtain it. How to do it? Elastic potential energy, what is the equation? What is the equation first? What is the equation of elastic potential energy? Equation. Half Fe, because we have applied some force, half Fe. Now, draw a rough sketch of graph, obtain it. Using half Fe, what is a graph? How about the shape of graph? Is there any intercept here? Is there any intercept? Now, elastic potential energy, E equal half Fe. Half Fe. Is there any intercept? No intercept. This is a graph. It is extension. It is applied force. Hari. Okay, if they given Hari, today you learn newly any practical. When we doing any practical, the dependent factor, the variable changing by us, it is always x variable. Dependent one x variable, and independent mean auto changing variable, it is always y variable. When we draw any graphs or when we prepare any equations, always independent factor y and dependent factor x variable. Take as x variable. Hurry. And if they any question given, draw a sketch diagram. Draw a sketch diagram for any straight line. First, you have to check is there any intercept or not. If it is intercept, if it has intercept එකක් තියෙනවා නම් you can't draw going through origin. Initial point එකෙන් අඳින්න බෑ. The reason it has an intercept. If there is no any intercept, you can draw like this. Okay, any doubt? Any doubt? Okay, now you have answers and go through mechanical properties of matters again and go through this question, and you can find another past paper questions. Now you can complete. මේ වගේ ගොඩක් practical questions කරලා බලන්න. අපි practicals කරනවා. We can complete practicals in after August in our revision. But now you can try. You have time. Nowadays you have time. Then you can try and complete as your maximum. Okay, then let's meet tomorrow morning with the second part of heat lesson. I posted your tudes Thursday due to our print shop delay that was late. Okay, if you not received, no problem. I will give you tomorrow a short note, then you can complete. Monday nang hambe duty. Monday hambe. And next Saturday, I'm going to discuss another lesson, rotational motion, advanced questions. Not too complicated. Normal exam level question is rotational motion. අපි ඒ වගේ forces කරමු. ඒ වගේ vast lessons, trigonometry. I will discuss all type of questions every Saturday. Therefore, don't miss Saturday class or Sunday class. Any class after tomorrow. Okay. Any doubt? No. Okay. Let's meet tomorrow morning. Good night.